Hi, this is how we look. This is my radio for the homework 4 probability. So the first problem we have a given y equal to gx, and we need to find the distribution function, density function of y in terms of the x. So first we can iterate that when y is when y is smaller than -1, the distribution function is equal to 0, and also when y is greater than 1, the distribution is equal to 1. This is according to the probability the property of the distribution function. And then for the y greater and equal to -1, smaller and equal to 1, we have at the point of -1, according to this, x is greater than 2, so we have the probability of y equal to -1 equal to the probability of x greater than 2. Then we equal to the 1 minus distribution function of x at point 2. This similarly we can do this so the probability of y equal to 1 is equal to fx1 minus ff0. So at the point y equal to 1, we have the probability of y equal to 1 equal to the fx0. So in the area of -1 to 0, this is the function gx function. So we can use the equation that the density function of y equal to the density function of x over the differentiation of x and its absolute value. So we have so x in this area, x is equal to -1 plus 1. So we have the density function of -1 plus 1 over 1. So it's distribution. So this is the value. So then we have the density function of y, which is when y is equal to -1, equal to 0, and equal to 1, do not forget the import function at this point, because this three is 3 points, so we need to add the import function. And also for y greater than -1, smaller than 0, we have this value. Otherwise, it's all 0. So then we need to calculate the density function. It's very easy to get the density function is 0, 1, and y minus function of x 2 plus function distribution function of 1. So this part is the tricky part. So when y is greater and equal to -1, smaller than 0, according to the definition, according to this definition, we can separate this with two parts. First part is when is the -infinity to -1. So we either together when -infinity to 1 is 0, and at point 1 the integration is according to 1 minus fx2. So and the second part is from the -1 to y, the integration of this one. So at this, and as the area of -1 to y at -0, well, we know that the density function of y equal to the density of x over and the bracket is 1 minus 1. So we change the variety from alpha into the -alpha plus 1. So and the second part we change the beta equal to -alpha plus 1. So this also changed by from alpha to beta. This value will become 1 minus 1. This two because it's changed to there is minus, so we need to add a -1 here. So then we have, according to this, so it's very easy to get this part. So for the x, for this part, we can easily, according to the density function, property of density function is equal to the integration from minus infinity to 2 minus the integration from minus infinity to 1 minus 1. So we can get this value. So this is the distribution function of y. And for the second question, we have x is uniform in the integral from -1 to 1. So we have this the figure for the fx, and the magnitude here is 1/2. And also we know the density function of y is equal to this. So we need to find the y equal to gx that satisfies this density function. So similarly, we can, according to the definition of the distribution function, is the integration of the density function. So we change the so we insert the density function of fy into the integration of this. So after the calculation, we can easily to get the 1 minus e to the minus 2y multiplied by the step function. And for the distribution of x from the density function of fx, we can integration of the 1/2 to get the distribution function of x is equal to 1 plus x/2. So easily we let this part is equal to this part. So after integration, we get y is in terms of x is y equal to -1/2 multiplied by ln 1 minus x/x. So this is gx when x is belong to -1 to 1. I mean for this part. So when x is greater than 1, this is definitely infinity. When x is smaller than -1, this is 0. So actually 0. So this the whole part is the y equal to gx.